All right, so this is a problem that's from the bonus assignment 31, the bonus videos, video 31 and assignment 31 that I posted. And so this is optional, and it will be an optional bonus question on the test, most likely. So it'll be very similar to this. One thing you want to remember is the parent function of a reciprocal. So a reciprocal function is this is the parent function, 1 over x, right? So it's just 1 over x. You have x in the bottom. And so what it looks like is something like this, okay? And what happens is you have a horizontal asymptote at y equals 0, which is also known as the x-axis, okay? And then you have a vertical asymptote along the y-axis, which is known as x equals 0, okay? All right? The domain is, you can see it goes forever to the left, forever to the right, but it does not include the middle. So you can say x does not equal 0, or you can say, or you can put negative infinity to 0 not included, so there's a parenthesis around 0, and always a parenthesis around infinities, right? And then you start at the other side of 0 and you go all the way to positive infinity, okay? So you can write it either way. These both mean the same thing. So that's the domain. The range is basically the same thing, right? It's y cannot equal 0, or you can do the same exact negative infinity to 0 and 0 to infinity, okay? All right. So, and we should actually, since we just kind of practicing some of our terminology, let's use the union symbol, okay, or the union symbol, not the intersection. And then the same thing with this one. This is something that we learned back in the day, so just want to incorporate it here. All right, so those are our domain and range. All right, so this is our parent function, right, that we just talked about. So now we're going to see here we have a reciprocal function. I can tell because x is on the bottom all by itself. There's no other x anywhere else. And so this is a reciprocal function. And we have a bunch of transformations going on, okay? So let's identify these things. So if we have a negative in the front, this means reflection. Across the x-axis. That's what happens when you have a negative in front there, okay? And then we have this plus 1 here. This, since it's with the x kind of inside, like we've talked about before, that's going to move it left or right. And positive, you would think moves to the right, but it's backwards. Everything inside is backwards, so it's actually going to move left 1, okay? And then this right here, this minus 2, this is a translation that's going to move it up or down. And since it's outside, it's going to, everything is normal, so negative moves down like you might think. So that's going to move it down 2, okay? And then this, this value here in the numerator is a vertical stretch by a factor of 3. Vertical stretch, okay? All right. So let's apply these transformations. So first of all, I look at the original. What's going to happen is going to flip upside down. So now my new graph is going to be like this, right? Instead of in the first quadrant, it'll be in the second quadrant. And I'm just going to kind of start with this center point here. And that's where the asymptotes meet, the vertical asymptote and the horizontal asymptote. And I'm just going to move that center point, okay? So I'm going to go left 1 and down 2. So I'm going to start here and go left 1 and down 2, so I'll end up right here, okay? And then I'm going to put in these asymptotes. So I'm going to put in the the vertical asymptote, okay? And now verticals are x equals a number, right? Here it's x equals -1 because it goes through -1 on the x-axis. And then the horizontal asymptote is going to go through that point again, and it's going to be y equals -2, right? Because horizontal lines are always y equals a number. So that's where we have our horizontal asymptote. We'll just call this HA for horizontal asymptote. And where we have our vertical asymptote, we'll call that VA. Okay, all right. And then now we're just gonna, we know it's upside down, so it's gonna be down here and up here, right? Instead of up here and up here, which is what the original looks like over here, right? Okay. And so, and then the other thing is the vertical stretch by a factor of 3. So that's just gonna make it a little bit steeper. So it's going to kind of, it's going to be a little less rounded, come a little steeper, go out that way. And this one's going to kind of do the same thing. All right. And that's it. So it doesn't have to be perfect. And don't worry about these too much. You know, just if it's, you know, if that number is bigger than 1, it's going to be steeper. But yeah, reflection. Left 1 and down 2, right? So just knowing what our original is. And I think I gave you a parent function handout a while back that has this on there. But you can definitely, you know, write this down in your notes and use it on the test, okay? All right, and then let's make sure we have everything. So x-intercepts. So x-intercepts we get by setting the function equal to 0 and solving for x. So if we put in, let's see, let's find that. So we'd put in 0 for f of x, right? Because everywhere along here is where y equals 0. So that's the x-intercept. So -3, x plus 1, minus 2. So what I would do is I would add 2 to both sides. And we would get 2 equals -3 over x plus 1. Then we could think of this as a fraction and cross multiply. So we would get 2 times x plus 1 is 2x plus 2. And then 1 times -3 is -3. And then we could subtract 2 from both sides. And we get 2x equals -5. And then we divide by 2. And so we get x equals -5 halves or -2.5, however you want to put it. And so -2.5 and so it won't be as steep as I originally thought, right? I should have graphed that. I should have plotted that first. So it's actually going to be, it's actually going to come a little less steep. Come through right about there, okay? All right, and then, yeah, there aren't any other x-intercepts as far as, let's see, yeah, domain and range. I forgot to do that. So this will be for domain. Since the vertical asymptote is at x equals -1, that means the domain is just x cannot equal -1, right? And then the range is going to be y cannot equal -2, right? Because those are where the asymptotes happen. Asymptotes, if you didn't watch the video, are invisible boundaries basically of a graph where they get very, very close. They approach those values, but they don't actually reach it, okay? And if they did ask for the y-intercept, we would just plug in 0 for x. So we'd find f of 0. Let's just do that. So that would be -3 over 0 plus 1 minus 2. So that would be -3 over 1, which is just -3, minus 2, which is -5. So the y-intercept would be -5, which we came pretty close to, right? So, yeah. All right. So I could have done a better job with that graph too, a little less steep than I thought originally. But remember, we're not looking for perfection here. We're just looking for a rough approximation and then just some of these key points identified.